Hello, everyone. My name is Carsten Roth, and I am an Alice PhD student at the University of Tübingen. And I'm very happy to be talking a bit about our work on waffling around for performance, where we essentially showcase very successful visual classification using random words and broad concepts. But more specifically, what we look at is the problem of open vocabulary, zero-shot image classification, where usually one utilizes VLMs like CLIP. It has two separate image and text encoders that map into a shared representation space. And the good thing is you can classify by simply contrasting an image against natural language encodings produced by the text encoder. Now, what has been recently shown is that you can very much improve the performance by augmenting the class name with large language model generated descriptions that are essentially associated to the semantic concept behind a class name. So for the case of a waffle, we could have like a photo of a waffle with a round shape, or which has a grid pattern, or with syrup toppings. And what you simply do is you aggregate a certain number of these descriptions, and then you just average the retrieval similarity computation. And this is essentially your output. And what ends up happening is that in doing so, you can essentially raise the performance of CLIP by quite a significant margin, like over percent across an average of a dozen visual classification benchmarks. Now, as it turns out, what we found is that you can get all of that, like the same gain, but you just drop the large language model and you simply average over what ends up being random words and random character sequences. And if you do this, we utilize the exact same process, but we simply replace these language descriptions. And what we find is that indeed similar performance, like if you look at the average performance on the very right side, and on specific benchmarks, we even outperform it. Of course, we underperform on some benchmarks, but it seems to work really well. And the good thing is, because we don't need any external model, it's actually a truly zero-shot setting. We just use the vision language model, and that's it. And so this input level noise averaging seems to work really, really well. Now, the whole reason we found this was because in the paper, we also advocate for certain sanity checks, which should be introduced or looked into generally when using large language models as an auxiliary mechanism to enhance non-language domain problems. And so, for example, in our specific case, we look at what happens when you change these description sets between classes, when you swap descriptions between each class, when you scramble descriptions, so you just scramble the whole sentence, or when you just kind of randomly assign descriptions between classes. And essentially in all of these cases, or in the majority of these cases, we see performance enhancement. And what we especially see is that the more randomized the setup gets, the higher the performance gain. And so this essentially drove us to simply look into WaffleClip from the word waffling and essentially just augment the input class name with noise variance. And this works surprisingly well. Now, the question is, if the noise setting, so if WaffleClip performs the same as a large language augmented model, which aims to introduce semantics, does this mean that semantics essentially hold no value? And it turns out that's really not the case. It's just how you introduce them. And in our paper, we also show that while WaffleClip performs the same as these large language model enhanced variants, the way they operate is not the same. And it's more different forms of structured noise. But what we found to be much better and more reliable to introduce semantics is, instead of using fine-grained descriptions, to go up in the hierarchy and simply utilize higher level, broader concepts. And in doing so, we get, as expected, quite significant performance gains, especially over vanilla CLIP. And what we tested is essentially if the semantics are actually a driving factor by simply exchanging higher level semantics between different data sets. And so what we end up finding is that swapping these semantics quite significantly drops performance in the majority of the cases, which means that it is the specific semantic context that actually drives the performance. Now, that's not all. Our paper contains a lot more experiments and insights, but as a final note, we want to highlight that we also compared completely randomized WaffleClip to handcrafted prompt ensembling. And what we found across an array of 14 different visual classification benchmarks is that WaffleClip outperforms comparable prompt ensembles more than prompt ensembles outperform CLIP. And so for the task of open vocabulary, zero-shot visual classification, we do believe that waffling around seems to be a pretty reliable mechanism to improve performance.